Barbara joins us from Google. She is a data scientist there, and she's going to give a view on the Kubeflow project and how that will run synthetically with the cell-before serving and deployment solution. So, Barbara, are you good?
I think so. Can you hear me?
Yeah.
Yeah, good. Okay, great. So I'm Barbara. So I'm actually not a data scientist. I'm a machine learning strategic cloud engineer. So I own all of the buzzwords in one title. And I joined Google, but just like last month. So all of my work that I will be showing you is purely research from before Google. I'm planning to be more involved with Kubeflow, but Kubeflow is an open source project. Anyone can be involved. Me being at Google doesn't put me in any better position than any of you if you want to join and collaborate. So, I'll be showing you a demo at the end, and it will be on Katacoda. Good thing is you can all use it. It's also on the Kubeflow page, so it's referencing to the Kubeflow. So very quickly, I'll tell you what I think machine learning is, what deep learning is, what AI is, and a quick introduction to Kubeflow, and then straight to them. Because we have like 20 minutes, there will be some questions at the end, but like keep them short if you want to have like a meaning of life discussion. We could always chat afterwards. I'm happy to do that.
Meaning of life conversations have to come with a beer.
That's true, that's true. Sorry? Right. Right. Yeah, you're right. So I'll be showing you the data science perspective. Saying that, I would like to say that I know just a little bit about Kubernetes. Like a little bit. I'm not really that interested in Kubernetes. So what I want to show you is I am a data scientist. I want to run some models. I want to do some machine learning processes. How do I do it? Using the tools that are there, but not really having a PhD in orchestration and ops stuff, etc., etc. So what's AI? Very quickly, because this is kind of a meaning of life question, right? What's AI? My favorite answer when I asked this question from the audience was it's matrix multiplication. And kind of is like this. And what I wanted to tell you is like, I'm not saying it's not amazing. It is. As, sorry, remind me. Andy said, we are in the middle of this revolution and something that is bigger than who we are. And it is great. It's just when you go down to earth into those algorithms, it's hardcore math. It's not magic, but it's kind of indistinguishable from magic. It can do miracles. Like, it can, recognize images, translate on the fly, do stuff that we didn't really think was possible, at least not by a human. Our machines are now passing Turing test. Isn't this great? And it's all because of the deep learning things, also those neural nets. So I'll show you very quickly how the history of deep learning looked like. When it started in the 40s, perceptron 57th, XOR problem 70s, multi-layer perceptron backpropagation algorithm that is being criticized a little bit nowadays, but still being used. 86. Some of you haven't been born yet. 2000s, and then there was like 2004, 2005, when I was considering my PhD and talked to my advisor, and he said, don't do those neural networks. Such a niche concept. Nobody is going to use it. Right? So I just chose genetic algorithms. And you know what? Such a niche concept. Nobody is using it at the moment. It's actually coming back, so I'm hoping maybe my knowledge will become useful. So now we have this big revolution. So what changed? Of course, a lot of change, because we had all of the tools and now we can use them. We actually now have a big data. Whatever definition you may have for the big data, we have tools to handle them. We have cloud. We don't have to buy the whole infrastructure. We have different training methods. The research is focused now on deep learning on neural networks. We have tools like Tensorflow, like Kubeflow, like Scalable, right? And what I personally think made deep learning and neural networks such a successful story was solving the biggest AI problem there is. Do you know what's the biggest AI problem? It's distinguishing cats from dogs. So, if you have it in a picture and you have to explain it to the computer to recognize it, you will fail miserably, and people did for years. And now we have layers, and yeah, now layers can do it. So TensorFlow is winning the popularity contest. If you go to like a benchmark size, if you see all of the comparison, TensorFlow may not always win, because there are some other networks who do this better and that better. TensorFlow sometimes wins. But it's definitely something that is well perceived as an open source project, has a great community, and it is working in actual production systems now. And the fact that it came out from Google, from the people that were actually doing stuff and open sourced it, really, really helps. Kubernetes. As I said, I like machine learning. I like data science. I not necessarily want to do the ops stuff. So my boyfriend is the ops stuff, and we try to he asked me questions about machine learning, and I'm saying like how to run this Docker container because I forgot this comment for the 10th time. So he made me bookmark some pages or just like tags our conversations through Facebook. So I remember that this was this comment that I'm asking for the 10th time. So Kubernetes, in short, why would you care if you're a data scientist? It's something that can orchestrate your containers, can do automatic deployments, distributed computing. And it's open source and comes from Google. Always helps, that's why it's popular. And again, it was used in some form in Google and being published to other people. So why would you consider using it? Because, well, that's actually what Andy was showing. Andy? Yeah, you or I don't know which one, maybe you were. No, that was Craig. Yes, Craig was showing it. All of the components that data scientists have to think about and hate to think about. We would love to have a tool to just say, I want to play with this model, I want to create this model, I want to read this data, I want to publish it, I want to consume it. And I want something to pipe it, do it, right? So Kubernetes seems like an obvious choice. It's just, well, Kubernetes can run anything, and I want it to be more dedicated to data science. Enter Kubeflow. That's what it is. At least that's where it's going. So composable, portable, scalable, all available buzzwords again. That's the dream. In my opinion, not yet there, but that's fine because it's a very new project. First time when I heard about this, it was December at KubeCon. And yeah, I loved it. Like, I loved the idea because, you know, what can you say from a short demo that was out there? And so there are three main components, and they change names. Like, for like 3 months now, they changed names in the public documentation. So there is a Jupyter Hub, there is a job operator, resource manager, depending how is it called at the moment on the documentation, something that takes your components, run them, think about attaching resources to them. And then there is TensorFlow model serving, my favorite part. So as a data scientist, there is like this big overall machine learning process. I do some experiments. Usually try to do them on my laptop first, like getting to know my data, and then my laptop is not enough, so I want to do something with more computing power, and I get the feedback, and yeah, something is broken, I need more power, so also I need to go to the cloud usually. Yeah, I used to work in Microsoft, so it was Azure, now it's Google Cloud. It could be some bare metal somewhere there. You may have some kind of a GPU stuff in your company if you're lucky. So I need something that is more structured and it's not just experiment. Experimenting is a big part, but I want the whole process to be there. So from my perspective, when I'm writing code, I want to experiment, but it's very often not enough to have it on my laptop. I need some computing power, even to experiment. I want to actually build some models. So, like playing with the hardware, thinking how I would utilize the CPUs, GPUs, how many threads do I need, how would this, in this phase I would need to think how would distributed computing look like for my algorithm. And the third part is actually, once I build this model, I want to publish it somewhere so people can use it. So either my dev team, when I'm building a recommendation engine, wants to use it on the side and display a proper recommendation, something like this. And as I said, I'm head ops, so I want to just do machine learning stuff. And I want to have a way to do it easily. So Kubeflow is telling me, for experimentation, use Jupyter notebooks, use TensorFlow jobs. For building models, you can build both, but like think of something more specific, so TensorFlow jobs. And for model serving, use model serving. As I told you, this is my favorite part. So I will show you that in a demo. You go to the link and you start a scenario. Basically, you can go through the steps. I will just show you that very quickly. So Kubernetes started. It's already deployed here on Katakoda. This is a platform that is available for you for free to use. And I didn't have to even log in, so you can see I'm still an anonymous user. So what I want to do is I want to see all the components. So I have those 3 components. I will be showing you a version from like early January, unfortunately, so I won't be using KSonnet, what Craig said. But KSonnet and the demos that are on the public Kubeflow side are following the same principle. So I'm not showing you how to use Kubeflow because there's plenty of documentation of how to do it. I will show you why I love using Kubeflow. So I can apply, so I'm using kube control, I think this is how you pronounce it, although I've heard like 10 different pronunciations, even kube cable. So it's applying those components there, and then I can see all of them here. So if you ask me a question, what does it mean, all those pods, and I have no idea. I just know it's work. I mean, I have some idea, enough idea, but like I cannot talk to you about details, and that's my point. So what I want to show you is the sample. So if you go to the Kubeflow samples, there is a smoke test that is showing you how to distribute the work of multiplying matrices. So, and it's distributing the work into different hardware components. So what I can see here is, I can see the whole specification. So I have a master, I have a worker, and I have 2 parameter servers. So this is my infrastructure. My code is in a completely different file, and my infrastructure is defined separately. And depending what I have in my infrastructure, this is how my code will be run. I just have to make sure that my code knows it will be distributed. And then you can just say, well, put some GPUs here, put some CPUs here. This demo doesn't use GPUs because they are expensive if you have them. But yeah, you can, if you have them in your infrastructure, you can add them to this configuration file. So what I'll do now, I'll just deploy this job. And once it's deployed, I can see if it's no resources still. No. And it just takes some time to do it. Yes. So this is those are the logs from the matrix multiplications. It's just, the job takes some time, distributes stuff, and then comes back. And those comments I was showing you, those are just to look at the jobs and their stages. So once now I want to set up a Jupyter hub. So there is a Jupyter load balancer here. So you could use it to actually gain access and have the link to Jupyter Hub. Who has ever used Jupyter notebooks? Okay, so you know how important it is in the experimentation phase. And so I can see the pods, but basically I think I can just click here. So it's configured to just use admin. You start your server, spawn with the default stuff. Come on. Let's copy to clipboard. And now we have a fully run Jupyter hub, and I can create a new Python and run some Tensorflow. It's a very simple hello Tensorflow, but yeah, basically you can do here and have access to all of the resources again. So this was Jupyter, and then my favorite part is model serving. So basically, if you have a model somewhere, I'm using the TensorFlow serving model inception, and I'm saying use this to look at Katacoda JPEG. So Katacoda logo looks like this. And yeah, apply it now. It's created, and now we can have to see. It's running. So yeah, comic book, rubber eraser, rubber pencil eraser, coffee mug. Not really, didn't. AI still needs some work. It didn't recognize a cat, right? I was just, trying to say how amazing it is because of the cats, but well, it needs some work. So, to summarize, I talked to you about machine learning AI, what Kubeflow is and how it's helping data scientists. And data scientists have to know enough of the Kubernetes or other technology to use it. How different components can actually help you when you're building your data science process, and showing you the demo. And again, this is something you can do on your own. It's available, either you remember it, go to Katacoda and look for Kubeflow, or go to Kubeflow main page, and the link is there also. So saying that, thank you very much. This is all I have to say.
As is the rule at these meetups, we try and save questions to the end when you can buttonhole our speakers and hopefully put a beer in their hand. But we will take a few quick questions if someone has one for Barbara right now. So raise a hand if you have a question. No?
Yeah.
Yes. Can you just give you your name and where you're from?
David Winter, I'm from Credible. It's a personal finance assistant company, just about to launch. You said that your code needs to be aware that it's going to be running on multiple CPUs. What do you mean by that?
So, like, I don't know why I was feedback, because I was standing by the microphone. So first of all, not all of the algorithms can be run in a distributed environment. So that's like the main condition to do this. And then some parts of your computations may not require, for example, GPUs, right? They could be fine with CPUs because they will be either short or they are not using the matrix vectorization. So GPUs won't help, really.
What about integer?
Sorry?
You can do matrix manipulation with integers, so maybe in that case.
Yeah, exactly. So maybe not then, but so you have to be aware of some low-level stuff, but like as I said, aware enough. Is that
Yeah, that's
answering your question? Thank you.
Do you have another question? Yes.
Along the same line.
Can you just give your name as well?
My name is Victor. Yes. Along the same line, trying to save the environment without burning or adding more to the carbon footprint. I know you're new at Google, but Google have TPUs rolling out. So when do you think those will be available? with GCP?
So I honestly don't know when they will be available. All of them, and even if I knew, I can only show you the public information. So
Views expressed here are solely of us.
So I would say use Google to find this information.
But it will save the environment.
You know, I'm not
By
that
contributing to
knowledgeable.
global warming by burning so much power.
One of the Google missions is actually to do that, so I'm guessing this will contribute to this goal. But again, I don't know the
I
details.
could probably answer this question better, actually.
Yeah.
ARM are building integer-based matrix manipulation. They're called network processing units. They're about at least 10 times more efficient with power than GPUs.
Yes.
Watch this space.
But
And also, NVIDIA changed their EULA so that you can't use GPUs for commercial machine learning as of whatever it was, January. So Google, amongst others, have to find a solution to this. So
But those kind of solutions will be more efficient with FPGA, which is available on Azure, because you can change the number of bits, right?
And
You can have a
maybe
4-bit.
Gentlemen, excited I am by this.
That's no remaining question.
Can I suggest that we park this one to the end?
Yeah. I don't think I convinced you to go back to Microsoft, so.
I sense some bias in the room.
No, I'm at Microsoft and Victor knows that, so that's it.
We're going to cut questions there. Apologies. Catch Barbara at the end. As I say.